I remember when I was at high school studying design and technology, where I was first introduced to 3D printing. I was absolutely hooked on the idea, so much so I wrote a paper about it and stayed after class to help build a RepRap printer for the workshop. That time, over a decade ago, was the start of a great deal of hype about 3D printing. We were told, here's a technology that can produce almost any geometry imaginable, and everyone will have one in their own home, like a Star Trek replicator. Alas, this is not the case. 3D printing is a disruptive technology and has been adopted in many sectors like aerospace, Formula One, dentistry, architecture, and, of course, rapid prototyping. But there are challenges that designers must consider when using 3D printing as a distributed means of digital fabrication. I want to highlight 4 key points: geometry, slicing, post-processing, and engineering. 3D printing can produce incredibly complex forms with negligible additional time or energy cost compared with a similar design of the same size. But not every shape can be 3D printed. If you're using FDM, you need to consider the support material for overhangs and bridges, stepping, and tolerances relating to wall thicknesses, detailing, and thin features. And with powder-based printing, you need to consider escape holes for enclosures. Check the links provided for tips on designing your geometry so it's suitable for 3D printing. The next thing to consider is that although your design might be suitable for printing, not all printers are the same. The print settings vary quite considerably depending on the filament, the model of the printer, and the environment. This is why 3D printed designs are typically shared as STLs and only sliced ready for printing by the fabricator on the other end. This has 2 consequences for the designer. 1, you have less control on the final outcome of the design. And 2, you rely on the person on the other end having the appropriate knowledge of slicing and 3D printing. These aren't necessarily obstacles, but they do need to be taken into account when designing for distributed, for end-use products. Post-processing is any step you need to take after the 3D printer is finished, but before the product is ready for the user. Typically, this means removing the support material. This can leave marks on the surface where the supports were, so take a moment to consider if the surface finish needs to be visually appealing. Finally, the engineering. 3D printed parts have layers, not dissimilar from the grain found in wood, in that the orientation of the part changes the strength properties. If you understand where the loads are being applied to the product when it's in use, you need to account for that in the orientation of the layers when it's being printed. Otherwise, you risk failure. This point could be at odds with my first point about geometry, in the sense that the optimum orientation for printing without support material could be directly opposite to what is required for maximizing strength properties. This is a problem that can only be resolved by setting priorities to the functionality and production of the design. In summary, 3D printing is a great technology and holds a lot of potential for mass customization and the production of end-user parts. But there's a lot that needs to be considered by the designer if they intend to use printing as a means of distributed design.